Hey everyone, sorry I'm out today. I'm home with my son, so we're going to do the best we can with this. So for starters, everyone should close their computers, and I want one person to turn on my computer and bring the video up so everybody can watch it at one time and we're all together on the same page. All right, so for whoever is subbing or in the classroom in charge, just have one person log into their It's Learning account, and then put it on the whiteboard for me, and then we'll go from there. All right, so this is a good time to pause and get that done. Everyone else needs to have their laptops closed. All right, so let's get started today. We're looking at 13.1, and the topic for today is the side splitting theorem. Oh, I'm getting used to the whiteboard on here, guys, so give me a second with my laptop. All right, so we're looking at the side splitting theorems. Now with this, you're going to need to be able to do your ratios. So if you're still struggling with ratios, you might want to go into the gizmos and go back and redo the ones on ratios that we did. If you can't find it, you can always Google it and it'll pop up, or go into gizmos and do a search and it'll pop up. All right, so we have a theorem that we're going to look at here, and it's the triangle side splitting theorem. So we have our triangle side splitting theorem. And you can find this, if you have not already copied down your theorems for this unit, you need to do that. You can find that on page 774. Okay? And it basically says if a line is parallel to a side of a triangle and it also intersects the other two sides at distinct points, so at given points, it splits these sides into segments of proportional length. Okay? So if a line is parallel to a side of a triangle and intersects the other two sides in distinct points, it splits these sides into segments that are proportional. Okay, so let's look at that. So if we have a triangle, and I'm going to see if I can do this on here straight, do my best. See if there's a button that'll allow me to do lines straight. We'll see what we can do. No, I know that does something. Oh well, I'm just wasting time. All right, so let's say we have a triangle. This triangle is not going to be exactly 90 degrees, or it's not supposed to be. Okay, so we have this triangle, and we'll call the triangle XYZ. Okay, and we have a line that goes across, and I'm going to do it in a different color, that goes across straight here. So notice that, well, let me label it, and we'll call this one AB. Very original. Okay, AB. And what you'll notice is this line is parallel to this line. Okay, and that's going to allow us to set up some distinct things. Okay, so we're going to have some proportional relationships going on here. So let's say let's say that ZY is 10 and ZA is 8. And let's put YB at 6 and AX at let's put this one at 10, and I'm going to change this one down here to 12. Okay, let's see if that works out. I should have put these together beforehand and see if they work or not. So let's look at what is proportional to each other, okay? So we can set these up as ratios, and I know this is a problem that we had in the past, okay? Just how to set them up and how to go from there, okay? So XB, okay, so I'm looking at right here, XB is going to be proportional to BY, is how we're going to set this up, okay? And that's going to be set up to XB here is going to match up to, are you ready for this? XA on this side. So this one's on top here, so we're going to put XA on top here. And then down here we have BY, and it's going to be proportional to AZ. Okay. So let's put in our numbers from there. Okay. So we know that XB is what we're trying to find. So that's going to be X. It's our unknown amount. And BY, BY is 6. Okay. And let's set up our relationships there. Stop. This thing is making me crazy. So we have XA is our next one. And XA is going to be 10. Okay. And then we have AZ, and AZ is going to be 8. Everybody with me? All right. So from here we can solve our equation and set up our proportion. All right. So if you're looking at solving this, there's a couple of different ways to solve it. I'm going to stay with the fraction idea here. And we want to isolate our x. X is being divided by 6, so I'm going to multiply both sides by 6. 6 divided by 6 is 1, leaving me with x. And then we'll just do our math here. 10 times 6 is 60. 8 times 1 is 8. And then I can simplify that down. Let me grab a calculator. I can simplify that down. 60 divided by 8. Oh, you can't see my struggles here, but they're real today. 60 divided by 8 gives me 7.5. So our value here for XB would be 7.5. Okay, so we're able to set up that relationship. Right? Now, if we want to find out what the value of DE is, I'm sorry, AB is right here. If we want to find out the value of AB, you can set this up as similar triangles, okay? So you can have, we can use our similar triangle, okay? Angle similarity, or corresponding lengths being equal. So you can say that, to find these two here, that triangle XAB is going to be similar to triangle X, Z, Y. Okay, so you can set in those values from there and find the base from that. And we've done similar, finding out what the ratio is going from one to the other. All right, it's going to be different than what we did up here. All right, so this is going to be different than that. If we're looking at the similitude to them, you got to find out that ratio of what we did to go from triangle XAB. So that's our smaller triangle. XAB is 10 here, 7.5 here, and that's our unknown. And then we have our big triangle. Now I'm running out of space on this page. And if we're looking at it, it is 10 plus 8. The big one's going to be 18. 7.5 plus 6 is going to be 12, 13.5. And then the bottom is going to be 12. Okay, so here we're just going to our similitude. What is our ratio or our unit rate of what we did to get from this triangle to this triangle? All right, so it's just trying to figure out what that is. And we know we're going to go from bigger to smaller. So our numbers should be so that it makes our numbers smaller from there. Okay, so you might want to go back and review if you don't remember how to do that part. Review, 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 because you've got to be able to know how to do that. Okay. All right, so that's the first one. That's the side splitting triangle part on page 774. And what I want you to do is we're going to pause here, and I want you to do a practice problem. Okay. I want you to do page 778. Let me find a different color pen here. Page 778. All right. 1 through 6. All right. Page 778, 1 through 6. And then I want you to submit them online to the assignment page on It's Learning. Okay, are we all good? All right, now, once you commit this to your It's Learning thing, then you're going to come back and do the second part of this video. All right, so this is the first part. I'm going to give you 15 minutes tops, 15 minutes max to do this and submit it, and then we're going to move on. All right, guys? So pause me here and then come back to the second video.